So in this video we are going to study more properties about double integration and triple integration, and we are going to look in detail about how to solve each of them. So let me first give a basic introduction. So this type of an integral, you see, so 0 to 1 ln of 1 minus x by x dx, this is a kind of integral which is required in more places than not, mostly in physics or sometimes in economics, and it's a logarithmic integral. And very surprisingly, first of all, a not surprising fact is that the integral is negative. This is because 1 minus x belongs to 0 comma 1 when x belongs to 0 comma 1, and this is true. Then ln of 1 minus x is less than 0, since these are the properties which are going to use. Now obviously these properties may hold true for all real numbers, but when it comes to complex numbers it becomes a bit difficult. What I mean by that is, say z equals to a plus ib, and mod z is basically root over of z into z bar. Okay, this means mod z is equal to so this is a complex number. And now when you are trying to find the complex number, the logarithm of a complex number, which is basically logarithm of z, now things may not be as simple as it were before, because the logarithm of a complex number is itself a complex number. Now obviously, since we know from Euler's theorem that and also by De Moivre's theorem that cos theta plus I sin theta plus multiplied by cos alpha plus I sin alpha and stuff like that, they are multiplied together. Now why that happens is a keen question we would like to ask, and we notice that here log of z is basically evaluating logarithm of a plus ib. Okay, this means that we have since mod z is equal to and z equals to mod z into e to the power I theta. So this is what we called Euler's form. So this is derived from the fact that the polar form of a complex number is as follows, and I'll show you how to get that. the polar form of a complex number is where theta equals to tan inverse of b by a. Now, why is this true? I mean, why do we get to write this thing like this? Well, the simple explanation is by using the Argand plane. So let me show you why that happens. In the Argand plane, what happens is you have this two axis. This is the real axis for z, and this is the imaginary axis for z. Okay. Now a plus ib is a point here. This point is a comma b, and this point is origin. So every point here is a complex number. And by coordinates, when I write a complex number in the form a comma b, it corresponds to the complex number a plus ib. Okay. Now you see, if you draw a line from here to here, and you draw perpendicular from p to this point and name it as r, you see that OR, the length of OR is basically a, right? And the length of RP is basically b. So it seems that OP's length by the Pythagoras theorem should be OP squared equals to OR squared plus RP squared. So therefore OP should be a squared plus b squared. Now, since OP is a squared plus b squared, and let this angle be theta, we are trying to write down a and b and like that, right? So what we can do is we can write, taking the cos of this thing, what we will get is cos theta equals to OR by OP, right? Similarly, and let's evaluate this first. OR is basically a, and OP is root over of a square plus b square. Similarly, sin theta is b by root over a square plus b square. Right. From this we get that a is equals to root over of a square plus b square cos theta, and b is equals to root over a square plus b square sin theta. And thus we can write z, which is equals to a plus ib, is equal to root over a squared plus b squared common cos theta plus I into sin theta. So this is basically the polar form of a complex number. And the Euler theorem basically says that it says that cos of theta plus I sin theta is equals to e to the power I theta. The proof of this would be given in the next one, and this would be how we are going to evaluate Euler's theorem, and then eventually we would get to De Moivre's theorem as well, because this use of complex numbers would be necessary in order to understand the complex integrand functions and also eventually Green's theorem. So solution number 1. Now given f of x is equals to 3x square plus 5x to the power minus 3, right? Now we want to have the derivative of this thing. Now if we remember correctly, whenever we have sum of two functions or two or more functions and we were required to find the derivative, we use the actual formula that derivative of sum of two or more functions is equal to sum of the derivatives of the function. So what we do is we individually differentiate each of the terms, like 3x square here and 5x to the power minus 3 here, and we can just write the answer as follows, right? So what is the derivative? Well, for polynomials of the form x to the power n, we remember the answer is n into x to the power n minus 1, right? So this would give us 3 is a constant which shall remain as it is, and for x square we should have 2 into x to the power 2 minus 1. Similarly for the other one, we should have 5 as it is, and then we should have minus 3 x to the power minus 3 minus 1, right? According to the rule, and I'll just write the rule here. ddx of x to the power n is just n into x to the power n minus 1. We are following this rule, right? So this would give you 6x minus 15 by x to the power 4. This is our required answer for number 1, right? Okay, so this was a bit easy. Let's go for number 2. Given f of x is sine of log of root x, right? Okay, now firstly we would like to explore some properties of log. So firstly, since log of x to the power a is just equals to a log x, okay, so it is true for all real a. In fact, so since it is true for all real a and a not equals to 0 would be the only factor, because the other then only the value of the log becomes 0, and we do not really need this. But in that case, what we can write is f of x equals to sine of half log x, right? This is because root x is simply x to the power half. So sine of log of root x would be sine of half log x. Now, remembering the chain rule, we understand that this is a composition of two functions, right? If we were to write the composition as follows, we can do it like this. Let f1x equals to sine of x, and let f2x equals to half log x, right? Then we can write f of x equals to f1 f2 x. So f1 of f2x, which basically means this is just f1 of f2x. And the chain rules said us that when we differentiate a function of this composite kind, what we get is f dashed x should be equals to f1 prime, and the argument should be f2 of x multiplied by f2 prime of x. Okay, so how do we do that? So we need to find the derivative of f1 and f2 first, which are basically the standard derivatives. Since f1 of x's derivative is just cos of x, and f2 of x this derivative is just half, will remain as it is because it's a constant, and log of x evaluates to 1 by x. Therefore f dashed x should be f1 prime of f2x into f2 prime x, right? This would give me cosine of 1 by it's actually f2x, so not this. So cosine of half log x by 2x. This would be your answer for the derivative. And just using chain rule, as I've told you, by using the method of layers to find out what function comes first, and we go all the way up to the function x. We can also see using that first here sine comes. So if we first write cosine of x, where x is this thing, then we go inside sine, we have half log x, so we differentiate half log x to find it is 1 by 2x, and we just multiply it by 1 by 2x. So in both ways it can be done, and it's not really very intuitive, but obviously it's a good practice for the problems that we have done before, and typical problem for chain rule. Next one, e to the power 5x log of sine of e to the power x. So this is our given problem, and if we wanted, we can actually use the chain rule again, and we would have to, but we would try it in a more fashionable way like this one, so it is easier to understand and not just some random answer. Because when we use the chain rule for real, we use the theory of composite functions, we actually get a good idea of what's going on and a better method to solve every problem, right? So first of all, this is a product of two functions, right? So let u of x equals to e to the power 5x and v of x equals to log of sine of e to the power x. Okay, and by using the derivative of product of two functions, we get since f of x is just equals to u of x into v of x, what we get is f dashed x is equals to u prime x into v of x plus u of x into v prime of x, right? So this is the formula, and since u of x equals to e to the power 5x, this one is an easy one to derivative because you just find out the derivative of e to the power x first, which is e to the power x itself. So this thing will repeat itself multiplied by 5 because of the 5x. Okay, so this is just 5 e to the power 5x. Now for vx, things are a bit different. So also vx equals to log of sine of e to the power x. So it's a triple layered function, right? So let us do that in a more systematic manner of how I'll show you how to do it in a more systematic manner using the chain rule only, and not using the fact that we first do it log and then we do a sine and then we do a exponential. Okay, so let v1 of x equals to log of x, v2 of x equals to sine of x, and v3 of x equals to e to the power x. Then v of x is simply v1, v2, v3 of x, right? It's a triple composition. Now how do we do something like that? So to do something like that, what we do is we consider g of x equals to v2 and v3 of x, which simply is sine of e to the power x. Okay, then v of x would just be equal to v1 composition of gx, right? By chain rule, v prime of x would just be equal to v1 prime of gx into g prime x, right? Now what is v1 prime x? We know, since v1 of x is log x, then we know that v1 prime of x is just equals to 1 by x. Therefore v prime of x would just be equal to 1 by gx into g prime x, or in other words g prime x by gx. Okay, now to find gx, since g of x is equals to v2 composition v3 of x, or in other words v2 of v3x, then again by using the chain rule, we have g prime of x equals to v2 prime of v3x multiplied by v3 prime of x, right? So this v2 prime of v3x into v3 prime x, and we can see that v2x was sine x and v3x was e to the power x. So their derivatives in fact are v2 prime x would give you cosine of x or cos x, and v3 prime x would be e to the power x itself. Then since v2 prime x is cos x, this becomes cosine of v3x, and v3 prime x is just e to the power x, so it's e to the power x. So this becomes e to the power x cosine of e to the power x, right, which is g prime of x. Then the actual answer would become, therefore v prime x would just be e to the power x cos of e to the power x divided by sine of e to the power x, which would just mean e to the power x cot of e to the power x. This is v prime x, and we go back to the top and we see that u prime x was 5 e to the power 5x. Therefore since f dashed x is just equal to u prime x into v of x plus u of x into v prime x, we can see it is equal to 5 e to the power 5x into e to the power x cot of e to the power x plus e to the power 5x. Actually this one would be only vx, so not this part. So it should be 5 e to the power 5x, and vx is just sine of e to the power x plus e to the power 5x into e to the power x into cot of e to the power x, right? And what we can do is as follows: we can take e to the power 5x common. What we get is 5 sine e to the power x plus e to the power cot of e to the power x, which is the answer for our derivative. So as you can see, this question was on the harder side of the derivatives, so we needed to have some composition to do that. Then again we can do number 4, but first 1 and 2 were a bit easier, but then 3 was a bit tougher because of the composition and the number of functions involved. So that's how we use chain rule to advantage. We try to break it one by one, and we try to find the exact answers by following the rules of chain rule, right? So it's not really that much of a hard task, but then again it's not an easy task either. So you need to understand the concepts very well. The fundamentals should be grounded to you. Okay, number 4. So number 4 was root x sine of root x. F of x equals to root x into sine of root x. So firstly, as we can see, it is a product of two functions, namely, so let me write down the names for these functions. Ux equals to root x and v of x equals to sine of root x, right? So what we can do is we can firstly write that then f of x equals to u of x into v of x, right? Then by the product rule, f dash x would be equal to u prime x vx plus ux v prime x. Now u prime x is an easier one because it's just x to the power half. Now u prime x is just like ddx of x to the power half, which basically is half into x to the power half minus 1, or this just becomes 1 by 2 root x, right? But for vx, since it's a composition of two functions, what we define is as follows. We define v1 of x equals to sin x, v2 of x equals to root over of x, right? Then we have v of x equals to v1 composition v2 x. Well, obviously v2 is equals to u, but we can just have a different name because it's in a different function, so it wouldn't matter that much. Now, using the chain rule, we have v prime of x equals to v1 prime of v2x into v2 prime of x, right? And we know v1 prime of x is cos x, so it's basically cosine of v2x into 1 by 2 root x, which just gives me cosine of root x by 2 root x. And when we put that back, what we do get is as follows. So putting everything together, our actual answer to f prime x would be So u prime x was 1 by 2 root x, and v of x was, I think, sine of root x, plus u of x was just root x, and v prime x is cos of root x by 2 root x. This gives us sine of root x by 2 root x plus cos of root x by 2. So we can just simplify it and do the LCM to write this as 1 by 2 root x into sine of root x plus root x cos of root x, which is the answer to this problem. So as you can see, this problem was also a little bit on the difficult side, but then again, all of these problems are a bit on the difficult side. We will try to do a few more problems in the next lecture on derivatives. Only after then we can move on to integration and its basics, because the chain rule and all of this must be very clearly understood before we can move to anything else. And there are a lot of things in derivatives that we will not be doing, like mean value theorem, which should be saved for the derivative section, and we will be covering all of this back when we will be covering calculus alone and not probability. But for now, doing a few problems on chain rule and how to understand this is enough, I think. So we did problems like this where the differentiation was of sine of log of e to the power x and stuff, but as I would feel that these things were not really very clear because I only provided you 3 or 4 examples. So what I feel like is at least 5 to 6 examples are required in order to be proficient, or even at least to be completely understand what the topic is actually telling you, or to have a first hand practice of it. So I hope that all of you would be doing this along with me, or maybe trying the problems first before you see me solve them. So that would be very helpful. So let us do a few more solved examples. Okay, so find the derivatives of the following functions. So this basically is the heading topic for this whole section, and I'm going to try one problem at a time, and then we can solve it, understand it, and move on to the next problem. So for our first problem, I'll just give you a function in each problem. So what I want you to do is to try out the derivative of this problem on your own, and then come back and see that if this matches with the answer and the procedures that I have done. Okay, so first problem is yes. So this is our first problem, where it basically means this is log of e to the power sine x whole squared. I want to find the derivative of this function. Okay, now as I've said before, since this is a composite function, we really need to understand what is the outer layer and what is the inner layer here. So to solve this problem, define the following pseudo functions. So what are the pseudo functions that we are going to define? Let's do that. f1 of x is equal to x square. We are going to define this x square function Well, because obviously the first thing that we see here is something squared, right? So we really need to have this, but we just don't know in which order it will come, but that we can figure out for later. The next function that you can see in the picture is also a logarithmic function, so it's like log of x. We also have an exponential function, so it would be f3 of x equals to e to the power x, and a fourth function which would be not e, it would be sine x, right? Yeah. So this is our total thing, and now we can write the function f of x as f of x is equals to, so what do we actually want to do? We want to see that the first function is the squared, the next is log, next is exponential, next is sin x, right? So our function is basically f1 composition of f2 composition of f3 composition of f4 of x. So this basically is our function. Okay, so if I were to write it in functional form, it would be something like this: f1 of f2 of f3 of f4x closing f3 closing f2 closing f1. So this would mean the actual function. Now, well, we need to be dealing with certain functions, because when we differentiate f dash x using the chain rule, these things come. So let g of x equals to f2 f3 f4 and h of x equals to f3 f4. Then g of x is also equal to f2 composition h of x, right? So we first basically would start with h of x. Now we see that h of x is equals to f3 composition f4 of x, which essentially is f3 of f4x, right? Now f3 was e to the power x, f4 was sin x. Then by using the chain rule, we can see that h prime x is equals to f3 prime of f4x multiplied by f4 prime of x, right? So this would be the meaning of this functions, right? H prime x. Now obviously this is the chain rule, and for that we need to find the derivatives for f3 and f4. So since f3 of x is e to the power x and f4 of x is sin x, we know that f3 prime x would be equal to e to the power x itself, and f4 prime x would be equal to cosine of x, right? Yes. So f3 prime x would be e to the power x and f4 prime x would be cosine of x. Therefore, the final value, the value of h prime x is given as h prime x equals to
f3 prime of f4x into f4 prime of x, which means it's basically e to the power sin x into cos x. So this is our number 1. So once we are done with h prime x, we would like to go on to g of x, and f2 is basically log x. So now we are given that g of x is equals to f2 of hx, right, which is basically f2 of hx. So using the chain rule, we have g prime of x equals to f2 prime of h of x multiplied by h prime of x, right? So h of x was, let us check, it was, I think, e to the power sin x, something like that, right? Yes, it was e to the power sin x. So, and f2 is log x. So we know that f2 prime x is just equals to 1 upon x, right? Because since f2 of x is logarithm of x, where log is the natural logarithm, the derivative of that would just be the reciprocal of x, because that's the standard derivative which we have evaluated many times. Now this gives us the answer that therefore g prime of x would be equal to 1 by h of x into h prime of x, and putting the value, we do get e to the power sin x into cos x divided by e to the power sin x, which gives us only cos x, right? So it's a pretty simple one this time. Now that we have g, we can write capital Fx. Finally we see that f of x is equals to f1 composition g of x, right, which can be written as f1 of g of x. Therefore using the chain rule, we have f prime of x equals to f1 prime of gx multiplied by g prime of x. Okay, now since f1 is just a polynomial, since f1x is just equals to x squared, we know, using the rule for the differentiation of powers of x, we know that ddx of x to the power n is just n into x to the power n minus 1. So here also we can easily write this is equals to 2x, right? And that would actually do it, because then f prime of x, which we actually wanted, would be 2gx into g prime x, right? Now what was gx again? Gx was f2, f3, f4, so it was log of e to the power sin x, right? And g prime x was just cos x. So this was 2 into log of e to the power sin x, and this was just cos x. And since you know log of e to the power sin x with base is just sin x, this becomes 2 sin x cos x, which just gives you sine of 2x, which is a multiple angle formula. It's a double angle formula here, which is our answer. So this was again a problem where we need to use the chain rule effectively. So what I'm trying to do here is to find different kinds of derivatives in order to make sure that we understand what's going on, right? Okay, let's do another one. Problem 2. Find the derivative of f of x equals to x square plus root x whole to the power sin x plus log square x. This thing is the function which we are given, and we need to find the derivative of it. Now obviously this is the problem where things start getting a little bit more difficult rather. So we need to understand what's going on first and how to solve this kind of problems in general. So as you can see in this problem, we actually have some x square plus root x thing, and we have something in exponent to that, right? So we generally do not have that, but we do have here. And to solve this kind of a problem, we need to be thorough about what we are trying to do. So the general technique for solving problems which have like this unorthodox exponents and the basis, what we do is follows. We try to take the natural logarithm of both sides because of the properties of logarithm, which transforms the exponent and it makes it a coefficient, and we can just evaluate it in terms of log. But then again, what does it mean for the actual function? So given f of x equals to x square plus root x to the power sin x plus log square x, right? And since it was given, we can see that taking log on both sides, we have log of fx is equals to log of this whole thing x square plus root x to the power sin x plus log square x, right? Now since we know that logarithm transforms the exponent into coefficients, we can write it like sin x plus log square x and let us define this as a new function. So let us say this is something like h of x equals to log of fx equals to this. Okay, so we are rather interested right now in finding the derivative of hx. So we are interested in finding h prime of x. So this is the function obviously, and it's a product of two functions, and we know from product rule of differentiation that the product rule says that if fx is equals to f1x into f2x, then f prime of x would be equal to f1 prime x f2x plus f1x into f2 prime x. So we can use that to our advantage to find that the derivative of hx ddx of sin x plus log square x into log of x square plus root x plus so this is the derivative for h prime x, right? So let me find out that for obviously when finding the derivative of sin x plus log square x, the derivative of sin x is pretty much simple, but the derivative of log square x is again a composite function. So let us define like this: let p1 of x equals to log square of x, which we want to find, and for that let us define two more functions: p11x equals to log x and p12x equals to x square, right? Then p1 of x is just p12 composition p11 of x, because it is just log of x whole squared, right? So this would mean that this is equals to p12 of p11x, and by using the chain rule we have p1 prime x equals to p12 prime of p11x into p11 prime of x. So what is p12 prime x? So we know that since these are basic derivatives, we can list them out collectively, that p11 of prime x is just 1 by x and p12 of prime x is just 2x, right? So therefore p1 prime x would be equal to 2 times 1 by x in it won't be 2 times 1 by x because p11x is just log x, so 2 times log x, and p11 prime x is just by x, so it's like 2 log x by x. So this is our p1 prime x, right? So this is one of the functions we wanted to evaluate, and another function we want to evaluate is log of x square plus root x. So let's just evaluate that as well. Let q of x equals to log of x square plus root x, and we define q1 of x equals to log x, while q2 of x equals to x square plus root x. Then we have q of x equals to q1 composition q2 of x, right? So this would mean it is basically equals to q1 of q2x, and by using chain rule we have q prime x equals to q1 prime of q2x equals to and let us do this later because we first need to find out the derivative for q1 and q2. So by basic derivatives we know that q1 of x derivative is just 1 by x, and for q2 of x we have ddx of x square plus root x, which basically is 2x plus, and the derivative for this is basically 1 by 2 root x. So this is the derivative for q2 prime x, right? So what we do get is this. Therefore q prime of x is equals to, so 1 by q2x was 1 by x square plus root x, so 1 by x square plus root x multiplied by 2x plus 1 by 2 root x. So once we simplify this, what we get is something like this: 4x to the power 3 by 2 plus 1 by 2 root x whole into x square plus root x. This is the derivative for qx. So once we have completed our qx and our p1x, we can find out the derivative for h prime x now, which is not really that hard. So what we can do is this. We know that h prime x is just equal to sin x plus log square x into ddx of log of x square plus root x, and plus ddx of sin x plus log square x into log of x square plus root x, right? Now this is the derivative of log of x square plus root x. This is 4x to the power 3 by 2 plus 1 divided by 2 root x whole into x square plus root x. So what we do get is this: sin x plus log square x into 4x to the power 3 by 2 plus 1 whole divided by 2 root x into x square plus root x plus, and the derivative for this is basically cos x plus 2 log x by x into log of x square plus root x, right? Now this is the derivative for h prime x, but we actually wanted to find f prime x, and we do remember that we had defined h of x equals to log of fx, right? So to find the derivative, we see that h of x is basically equals to h1 composition f of x, where h1 of x is just logarithm of x, right? So by chain rule, h prime of x equals to h1 prime of fx into f prime of x, right? And since h1 is logarithm, the differentiation of logarithm is 1 by x, we can say this is basically 1 by fx, and this remains f dash x, as we do not know f dash x yet. So this becomes f dash x by f of x, right? So we see that therefore f dash x should be equals to h prime of x into f of x. And to quote the whole answer, we can write the final answer is f prime of x is equals to x square plus root x to the power sin x plus log square x multiplied by sin x plus log square x into 4 x to the power 3 by 2 plus 1 whole divided by 2 root x into x square plus root x plus, so the next term was cos x plus 2 log x by x into that. So cos x plus 2 log x by x into log of x square plus root x. This is the final answer. So as you can see, differentiation of that function x square plus root x whole to the power sin x plus log square x was a tad more difficult than we would have thought it would be. But then again, differentiation is sometimes tough. Yes. So this kind of problems might appear in your competitive examinations, in your college examinations, in some platform where you solve problems. But the steps that I have followed here, all of the steps, they are necessary for a complete solution. Otherwise it's just second guessing the solution. So we really need to do all of this. Obviously you can do it in one line. If I wanted to, I could have done in one line, but that's just my thought process, right? So but when you're doing it in pen and paper, you need to write every piece of your thought which makes sense logically, and why a step follows after the next one, and why, and nothing is obvious. So you just have to explain everything. So you just cannot use the chain rule blindly. So you need to provide explanation for why each and every step works, why the derivative of such a big composite function would result in finally something like this, right? Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel.